All right, all right, all right. Good evening, good evening, good evening, good evening to grade 12 students. Welcome back, welcome back. Welcome back to one more session of your board examination preparation. We are left hardly with 1 week. Nothing to worry. Yesterday's video, I have sent aldehydes, ketones, and acids in just 5 pages. Correct, students? Have you all done that video? Have you all completed studying that? Study this. If you study that, you'll have an understanding of the chapter. Now, in this particular video, I'm going to do completely nomenclature will be done, name reactions, distinguishing test, conversions, word problems, reason-based questions, and MCQs also. Without wasting time, as time is precious, let's start the series. To all the new students, welcome, welcome. To all the old students, God bless you all and thank you so much. So God bless all of us. But my gratitude to all the students who have been the strongest support to the channel. Thank you so much, students. Let's start the question. The first question says, write the reagents required in the following reactions. Reagents are very important. That's why in aldehydes in 5 pages, I have explained all the reagents carefully. Now, in the first reaction, see this, there is one OH group, alcoholic group, there is CHO group. So what is happening in this case? They're asking me reagents. There is also a double bond. There is no change in the double bond, nothing. But here you are trying to convert alcohols to aldehydes. You very well know alcohols, the two primary alcohols. Primary alcohols on which part they get converted to aldehyde, students. Further, this also gets converted to acids. You should be careful, right? But what are we doing? We are trying to control this reaction here. So the reagent which control oxidation is nothing but PCC, correct? So the first answer is PCC. PCC is pyridinium chlorochromate, which helps in giving us controlled oxidation. I'm stopping that. There is one more reagent like copper at 573 Kelvin. What does it do? It does dehydrogenation. So dehydrogenation also does where alcohols are converted to aldehydes through a process called dehydrogenation reaction. So these two reagents will help me in conversion of alcohols to aldehydes. So the first reagent is this. Next question. What did they give me? CH3COH2, CH3CONH2O. Nice. What extra is there here? Instead of OH, there is NH2. Only tell me, students, what is the reagent which adds NH2? Nothing, right? Ammonia is a second reagent because it is getting converted to NHCH3CONH2. So ammonia adds, and along with that, heat also is required to simple, simple question. Nothing. Gradually we will go and we will understand. Let's see one more question. If I'm going fast, let me know, or you can reduce your settings. Okay, chalo, let's start. Complete the following reactions. What did they give me? They have given me formaldehyde and they have given me KOH. Oh wow, I very well know. What is this KOH used to see? Sodium hydroxide. I very well know. I'm using it in aldol condensation. Correct. When I'm using KOH, wherever I'm using this, I'm using KOH in terms of. Can you just tell me, students? Yes, Canizaro's reaction. So as soon as a question is given, just understand and write the Cannizzaro reaction and leave it and we'll write the complete reaction. Now HNO3 plus H2SO4 is a nitrating mixture. Correct? This is a nitrating mixture. So what will it do? It's going to add NO2 group. So it is going to add electrophile, that is NO2. And what is NO2? What is it? It is meta-directing group. Correct? Na? It is meta-directing. So shall we write both the products? Yes. Yes. Let us start the reaction. First, do I have 2 pages? No, I have only 1 page. Let me start. The first one is I'm going to take formaldehyde, correct? How many moles? So H, C, double bond O and H. How many moles are there? 2 moles are there. This is your formaldehyde. I've just written. So what am I doing? I'm going to use, instead of writing together, I have written separately. Don't get confused. KOH. First, you very well know one is going to get converted to alcohol and one more is getting converted, one is getting oxidized and one is getting reduced, correct, right? So sorry, students. So the first one, how does it break? To make your work more easy, I'll first take out the COOK part. So COOK, see here, see this, I'm breaking this here, correct? So COOK. So first product is H is already there. HCO, sorry, H, take this. Oh, HCO, okay, done. Next product, what is left out? H, H, H is here, and your OH is here. So one gets oxidized and one gets reduced. So one is methanol, one more is your potassium formate. Correct, na? So in Cannizzaro reaction, same substance undergoes oxidation and also undergoes reduction. So instead of writing like this, earlier you would have written like this, na? HCHO. That's all. So one will become salt of it, one will become alcohol. In the second question, what do they give me? Nitrating mixture. This is my benzaldehyde. Okay. So I'm adding what mixture? Nitrating mixture, that is concentrated HNO3 and H2SO4. What temperature did they give me? They gave me, sorry students, they gave me at 273 to 283 Kelvin. 273 to, now I told you, right? It is your meta-directing group. So it goes and attacks at NO2 and this becomes CHO. What is the name of this compound? You need to write the name of the compound. So it is meta-nitrobenzaldehyde, correct na? Meta-nitrobenzaldehyde is a compound. Easy. So in the exam, you need to complete this reaction. You have to label it. You have to name it. Question is done. Chalo, next question. Let us read the next question. Yes, question. Very important question. This I named it as question 1 because I took it from a different book. Chalo, let's start. Now, addition of water to alkynes occurs in acidic medium and in the presence of mercury plus 2 ions as a catalyst. Okay. Which of the following product will be formed on addition of water to butanine under these conditions? Okay, this is a MCQ question. They have given me how many options? 4 options. So, shall we start writing? They said addition of water to alkyne. Okay, so I'm going to take, let us solve it. First of all, let me take symmetrical or unsymmetrical. Let me take an unsymmetrical alkyne because symmetrical, there is no much change in your compound, right? So I'm taking a symmetrical alkane. What am I doing? I'm adding water to this. In the presence of what? In the presence of, they've given me mercury, the presence of acidic medium and Hg plus 2. Okay, I'm going to take this acidic medium and in Hg plus 2 ions. Done. Correct. Now what happens according to the Markovnikov rule or anti-Markovnikov rule? So we are doing hydration. Basically, I'm adding water. How did I know this? They've given, see, addition of water. Okay. So I'm going to add this water around this triple bond. So this bond breaks and what will I get? I'm going to get CH3, CH2, C, OH is here, double bond is still there and this carbon, hydrogen is added. Correct? Further, what did they say? They said which one of the following product is formed an addition of water to butanine under this condition. That's the reason butanine initially unsymmetrical alkene. I have already taken butanine because here unsymmetrical alkene normally we tend to do with butane because propine, here you'll have an understanding of differentiation between carbon with less bonds and carbon with four bonds. Okay. Then they said, which one of the following product is formed in addition of water? So this is going to stay as a resonance hybrid of both. So you would very well know, right, the importance of double bonded arrow. So this turns to CH3, H2, the ketoenol tautomerism. Students, have you remember? Yes, something like that. So what did I do? I have taken out the bond. I've shifted removed the hydride H part, broken the bond and left out part is C double bond O. Correct? Right. So what is this question now? This question here, the option is B option. Correct? Na? I think let two concepts I've told here. So to check resonance hybrid, I said, ma'am, what is resonance? Where is the resonance here? So check carefully, students. I'm talking about the balance in the equilibrium state where this and this stays in equilibrium with each other. That's my concept. So next question, students. Which of the following compound is most reacted towards nucleophilic addition reactions? Okay, first of all, they have given me 1, 2, 3, 4 options. So nucleophilic addition reactions, first of all, I'll directly give you the answer and then explain. Okay, acetaldehydes. Why they are more this one? Because when I take acetaldehyde, let me explain this. See here, C carbon double bond O hydrogen. This is partially positive, this is partially negative, correct? Now, what happens in carbonyl carbon? What is the other next one given? Then given is acetone, ketone. Okay, this is two alkyl groups. Okay, done. So in first case, what happens in carbonyl carbon? They are polar, correct, right? With positive charge on the carbon atom and negative charge on the oxygen atom. Now, what happens when there's positive charge, carbonyl carbon, this particular thing, it can be easily attacked by nucleophiles. Correct, na? That is the concept. They asked me which is nucleophilic addition reactions, nucleophiles. Now, this is easy. Now, when I take the second one, okay, when I take take one more thing, partially positive and partially negative. Now, what happened here? There are two alkyl groups, correct? Both are electron releasing groups. This is also electron releasing, this is also electron releasing. Now, both are electron releasing groups. What will happen, students? Yes, already it is rich in electron. Now, when the nucleophile approaches, what will happen? Lot of electron density, there is no requirement. So, we are ruling out this option. Now, next, benzene ring. What is next option given? Benzene ring is given. Correct, na? So, this is your option C. Okay, option C, they have given me benzaldehyde. And option D, what did they give me? They have given me, okay, yeah, ketonic group. Okay, now you see in this both the cases, benzene ring, what does it exhibit? Exhibits plus R effect. Benzene ring, it exhibits plus R effect. So plus R effect, what will do? Because benzene exhibits plus R effect, thereby it will reduce the nucleophilic addition reactions. Reason in benzaldehyde and acetophenone, already plus R group is there. The electrons are rotating and rotating, rotating. Where will the nucleophile come and attack? So because of the plus R effect, nucleophilic addition reactions in benzaldehyde and acetophenone reduces. So which is the correct group, students? This is also ruled out. This is also ruled out. The correct option is correct. Now, next question. This page is blank. So remember once again, acetaldehyde in this case, concept number 1 in aldehydes, carbon has positive charge, hence nucleophile will attack. In second case, in terms of ketones, electron releasing groups are there. Electron releasing groups are more, so nucleophilic addition reactions is not much encouraged. Already the cloud is not much encouraged or encouraged. Now in this case, in third case and fourth case, what happens? In benzaldehyde and acetophenone, what is shown, students? Plus R effect. Benzaldehyde and acetophenone, both the cases plus R effect. That's why nucleophilic addition reactions are. Next question. The correct order of increasing acidic strength. Okay, increasing acidic strength, they said. Acidic strength, what does it depend upon, students? First of all, let me give you the answer and then mark the answer and then give you. Among all those, this one. Why did I take this question? First of all, see here, in case 1, phenol is more stable than alcohol. Why? Why? Because forms more stable conjugate base. Yes or no, students? Phenol forms more conjugate base after removing H plus. Ma'am, what is this? Let us understand. In case of phenol, see, phenol is here. I am going to take phenol. Now, the OH. So it is now acidity means release of protons. Okay, I'm releasing. So what does it do? It's going to form a phenoxide ion. Am I right, students? It's going to form a phenoxide ion. Okay. Now you only tell me this, whatever this is formed. Now phenoxide ion is more as an acidic, we say, right? Yes. So phenol is more stable than alcohol because it forms a conjugate base. Now this conjugate base is more stable, correct? So, right? Stable conjugate base. So because it is stable, will it release any proton further? No. That's why phenol is less acidic compared to ethanol. Okay, done. Now, next question, where is this? acetic acid. Let us take acetic acid. What is happening? Why acetic acid comes? Why acetic acid is at the next? Like it's here. Why is acetic acid here? Why am I not taking acetic acid? So in case of acetic acid, observe carefully, students. This is your CH3. This is your C. This is your O, and this is your OH. Correct. Now I'm trying to remove H plus ions, releasing proton. So what will you get? You will be getting a compound something like this. Yes. Now this is resonance stabilized to this. Correct now because of the shift of oxygen, shift of pi bonds. So these two substances are resonance stabilized. Resonance stabilized. Now you only tell me in case of acetic acid, the compound or whatever is there, this formation of stable conjugate base and phenol. But here in this case, in this particular thing, acetic the carboxylic acid is resonance stabilized. Can it donate proton? Hence it is less acidic. Now next, let's take chloroacetic acid. See here, phenol we have studied, acetic acid we have studied. In case of chloroacetic acid, this is chloroacetic acid, students. Why? What happened? In terms of chloroacetic acid, what is the problem with why? But see here, chloroacetic acid is more stronger acid than this. But here, chloroacetic acid, what happens here is, check carefully, electron withdrawing group is there, correct? So chlorine is an electron withdrawing group, and that too it is attached to alpha carbon atom, correct? That's why. So it is more acidic. See here, chloroacetic group is more stronger in this case because it is electron withdrawing group, and that too this electron withdrawing group is attached to which carbon? Which carbon? Alpha carbon. Once again, chloroacetic group, chlorine is attached to alpha carbon, and it is it is more electron withdrawing. That's why it is more more acidic. Okay, more acidic. Now go back to the question, understand again. So the first option I said ethanol is less acidic. Why ethanol is less acidic? Tell me what is happening. In case of ethanol, both are electron releasing groups. Correct? Na? We didn't write about that. Here only we will write. In CH3, C2, CH2, OH. Both are electron releasing groups. This also releases, this also releases. That's why electron releasing groups increases, acidity decreases. That's the reason I took the option ethanol is less acidic than phenol, resonance stabilized. Acetic acid also same, but here this is resonance stabilized. In chloroacetic acid, electron withdrawing group increases, acidity increases. Easy? Easy question. Let's do the next question. Next question. Compound. Okay. This compound is given to me. Alright. I don't know the name. Don't worry about the name. Leave it. But they said it can be prepared by the reaction of. They want this compound. First of all, what is this compound? Can anybody name it in the group, students? In the comment section? Chalo, I'll do the question. Now I want this, both these are phenyl rings. Okay. So shall I write this, expand it? H5O CO C6H5. Okay, I want this compound to be prepared. Alright. Now in this case, when you see, just cleave this bond exactly here. Okay, cleave this bond. When you cleave this bond and observe, there are two groups here, C6H5O, and one more group is C6H5C. So you remember, students? Remember, I can form two benzyl this particular compound by adding pyridine. Yes. One compound is phenol. Okay. One compound is benzoyl chloride, COCl. In terms of pyridine, what is this reaction? It's called Shorten-Baumann reaction. What is the reaction? Shorten-Baumann reaction. Correct? Now, what is removed here? This hydrogen and this Cl is removed as minus HCl. and you get a compound which is given above. So oxygen, C double bond O, and S. Easy? The question, students? Yes. So remember, that's the question. So note it. What is the reaction now? Phenol and benzoic acid can be prepared. Benzoyl chloride in the presence of pyridine can prepare this. So option B. Next question. Question number 5. Reagent which does not react with both acetone. Reagent which does not react with both acetone and benzaldehyde is. Okay, which one will not react with acetone and benzaldehyde? The answer is Fehling solution. Why? First of all, what is the role of Fehling solution, students? Yes, Fehling solution role, before I go to this question, let us write the role. Role of Fehling solution. The Fehling solution basically I'm going to use for oxidizes aliphatic aldehydes. It oxidizes aliphatic aldehydes. This is aliphatic aldehyde easily. Yes, easily it just tries to convert aliphatic aldehydes, but it will not react with acetone and benzaldehyde. That's the rule. So its work is to convert and form acids, oxidizing, but it will not react because of their benzaldehyde, because of their resonance. Correct? So only aliphatic aldehydes it does, but it will not react with acetone and benzaldehyde. There's one more reason also hidden in this. Can you just tell me? Yes. Can you just recollect and tell me in the comment section? Yes, there's one more reason. Very important and in-depth reason in this. Tell me in the comment section. Let me see. Right, students? Okay. Cannizzaro reaction is not given by. Okay. First of all, Cannizaro's reaction, what should you see? Alpha hydrogen. Correct? So, for Cannizaro's reaction, did I mark? Okay. Cannizaro's reaction. Mm, okay. First, check for alpha hydrogen. If you check for alpha hydrogen, then it's easy for me to mark. In case 1, which does not give it set. So here you have alpha hydrogen exactly attached to adjacent to this. Yes, the compounds have no. Okay, here alpha hydrogen exactly attached. What is alpha hydrogen, students? Basically, alpha hydrogen, or the hydrogen attached to the carbon adjacent to your functional group. Correct, right? Yes. Okay. So now in this case, okay, did we do something wrong? All right, let us once recollect. First of all, Cannizaro's reaction. Oh yeah, aldol condensation should look for alpha hydrogen. But in Cannizaro's reaction, alpha hydrogen should not be there. Correct? Yes. Once again. Once. All right, all right. I just got a phone call, students. All right. So basically, you have to check for alpha hydrogens. Ma'am, what is this alpha hydrogen Cannizzaro? Remember, students, basically, Cannizzaro reaction is given by, remember this, this is most important. Cannizzaro reaction is given by given by compounds, with no alpha, which does not have alpha hydrogen, which does not have alpha hydrogen. I just now said, right? What is alpha hydrogen? The hydrogen attached to the carbon adjacent to the functional group. Now, in all the cases, see here CH3CHO. Yes, does it have alpha hydrogen? Yes, because hydrogen is directly attached to the functional group. So this will not give anisaro. In this case, yes, it gives, this gives, this gives. But Cannizzaro is not given by. Remember, for Cannizzaro, they should not be alpha hydrogen at all. Okay, does not have alpha hydrogen. And then in CH3COH, it is directly attached to this. That's why it will not show Cannizzaro. Students, next question. Which product is formed when the compound CHO is treated with concentrated aqueous KOH? Concentrated aqueous KOH. Okay. Again, same, almost Canizaros only they gave. What did I say? For a Canizaro, because it shows proportionation reaction, right? Canizaro means KOH. Shows disproportionation. So one is oxidized, one is reduced. So in this case, which does not, what product they form? They ask me product. So let us check. Okay. So see, let us take this compound first. Okay. I'm going to take this compound, benzaldehyde. I'm going to take. Okay. After taking this benzaldehyde, what did I add? Concentrated aqueous KOH. Okay. Concentrated KOH is what I added. Canizaro's reaction disproportionation. What will happen? One will get converted to an alcoholic part. One that is disproportionate. One is getting oxidized, one is getting reduced, and one more compound gets converted to the salt of it. So one molecule of aldehyde is reduced, correct? Yes, one molecule of aldehyde is reduced and other is perfect. Right, what is a compound, students know? So this is your COOK and this is alcohol. Next question. Next question. They have given me, okay, they've given me alkyne. This is a sulfuric acid and mercuric sulfate. Okay, isomerization to acetone. Okay, this is one of the question which I did earlier. What is a product form? Let us take that reaction little bit and then start. So what did they give me? They have given me an alkyne. And what did they give me? They have given me 40% sulfuric acid and 1% mercuric sulfate. Okay. All right. So what does it do? Hydration. It does hydration, right? Right? Right. So it is going to break this bond and it is going to add according to, because it is unsymmetrical, the hydrogen goes and adds. The OH group adds to this carbon having less number of hydrogens, and to this carbon you have one more hydrogen. What is this name of this compound? This is prop 1-ene to all. Okay. Yes. This is done. Fine. This is which compound? A compound. Now what are you doing? They said this compound further is undergoes isomerization. That's nothing but tautomerization. Okay. Tautomers. So tautomerization, it undergoes. So is a tautomer or the isomer of this having the same number of the molecular formula? So that's nothing but acid. Correct, right? H3COC. Perfect. This is acid. Tautomers. Both are alcohol and your ketones. Okay. All right, tautomers. Now, what is the answer, students? Then the answer is prop 1-ene to all. This is the option. Okay. Next question. Compound A and C in the following reactions. This is a compound. Okay, they're asking you what is A and what is C. All right, so let us write the reaction first. Let us go to the next page and take. Do I have two pages? I have only one page. So I'll start writing here only. So first of all, I'm taking ethanol. Then I'm using Grignard's reagent, which adds. Okay, this is it adds, and it is also undergoing hydrolysis. So when I add Grignard's reagent, first of all right, what does it look? CH3 is here, your CH is here, your CH is here, your OH. Correct? Because I'm adding this particular carbon to aldehyde group. Here I have added this. Okay. Then the OH, the hydrogen, whatever is there, sustained there only. Now further, no, see what did I do? I directly did this because hydrolysis also is given. So I directly did this compound. Hydrolysis part also is over. Now what am I doing? I'm taking this. I'm using dehydration because sulfuric acid, what does it do? It does dehydration process. It removes water molecule. What does it do? From where it removes water molecule? Your hydrogen here and your OH here. Right? Correct? So and no, once again, the same carbon, no, one hydrogen, sorry, no, this is one hydrogen, sorry, students, not remove from the same thing, adjacent thing, right? Your hydrogen from here, so no, now we'll do it. So what happens? Your OH from here and your H from here, your OH from here and your H from here, and the bond shifts. How does it look? It looks like it is CH3, CH, CH3, correct? One OH from here, one uh, hydrogen from there, remove it. So it looks like a double bond which formed here and your hydrogen is here, correct? OH from here, H from here. What is this compound? This propene. This is part B. Now what did they do? Next they have taken and did hydroboration oxidation reaction. Hydroboration oxidation reaction happens in the presence of diborane, correct? Right? Then using hydrogen peroxide also. So hydroboration oxidation reaction depends on a base. So what happens in hydroboration oxidation reactions? Your alkene is getting oxidation, you're doing oxidation. You're breaking the bond and we form primary alcohols, right? In hydroboration oxidation reactions, this is your primary alcohol. This is what? Propan 1-ol, prop 1-ol, C compound. Now you only tell me, what did they ask me? They asked me A. They've asked me A. Propan, this is prop and 2-ol. They asked me A and they asked me C. What is the option, students? So, compound A and C in the following reactions are. So, I got A and C. What did I get? I got propan 2-ol. Here, C part, I got propan 1-ol. 2-ol and 1-ol are what? They are both a position isomer. Correct now? Here OH group is in the second carbon. Here OH group is in the first carbon. So both are position isomers. Am I right, students? Shall I go back and mark it? Answer B is a option. Okay. Next question. Is it a bit confusing? Not confusing. We'll gradually go and do it. Question 10. Which of the most suitable reagent? What is the most suitable reagent for the following conversions? Okay. What are converting here? What actually is converting? See here. Let's go with the functional group. We are not worried about anything. More worried about the functional group. Which is the most suitable reagent for the conversion? Okay. So what is this, students? This is a ketone group. What is this group? It is a methyl ketone. Okay. Here what is happening? This got converted to carboxylic acid. Correct. Now methyl ketones show which type of reactions, students? Which type of reactions? Yes, iodoform reactions. Correct. Iodoform reaction, remember? Write this reaction, just check. So the CH3 H double bond CH. Methyl ketones show iodoform reaction in the presence of iodine plus NaOH, and they are going to form first. Let me write step by step. It's going to form this compound COONA, yes, and along with that iodoform in a low color PPT. Further, what did they say? They said suitable reagent only, nothing. They didn't ask us the reaction also. Further, when I do this hydrolysis, what happens to this compound CONA? It's going to get converted to your acid group. It's going to get converted to your carboxylic acid. That's all. So what is the reaction when you see methyl ketone? Right? Yes, it is an iodoform reaction. Next question. Let us go. Which of the following compound will give butanone on oxidation with alkaline K-manophore? Okay, which of the following compound will give butanone? Okay, butanone. So they're asking me with K-manophore. What is K-manophore? It is nothing but oxidizing agent, but they gave me alkaline. What should I do? Oxidation only. They've given me oxidation, so what to get confused? So what did they say? Following compound will give butanone. Okay. So first of all, let us write the reaction. Butanone. CH3H2 COCH2. This is butanone, correct? Butanone. Now, how many carbons are there? 1, 2, 3, 4. So I also require again 4 carbons. 4 carbons. Which one has 4 carbons? Now in this case, where is the CO group? CO group is here. That means I have to take an alcohol. I have to take an alcohol in which the oxygen atom These or the alcoholic group is in the second carbon. See here. This is in the second carbon. Here also it should be in the second carbon. Yes, second carbon. So the option B. Let us write the reaction now. Go back. Take this. Write alkaline KMnO4 in this case. Take again butanol, CH3, CH2, CH, CH3 and OH. Now see here what happened. Alkaline KMnO4 oxidizes. What is oxidation? Oxidation is addition of oxygen or removal of hydrogen. So hydrogen from here is removed hydrogen, and you're getting ketone. See, so check wherever OH group is there, there only your CO group should be there. So it's easy for us to get. So but to all or butan to all got converted to butanone. Easy, very easy. Chalo, next question, student. Next question. In Clemmensen reduction, carbonyl compound is treated with Clemmensen reduction. Carbonyl compound is treated with Clemmensen reduction. Oh, right. Clemmensen reduction, first of all, is what, student? Clemmensen reduction is used to convert, or it is a type of reduction which uses zinc amalgam plus HCl, where it is used to convert the carbonyl group to your CH2 group. Correct na? Yes. So zinc amalgam and HCl, they act as reagents. These two are reagents. Zinc amalgam and your HCl are reagents here. Are reagents. Clemmensen reduction, simple. Okay. So here zinc amalgam and HCl. So option. What is the option, students? They are in Clemmensen reduction. Carbonyl group is treated with zinc amalgam and HCl. This B should come here. Sodium amalgam, zinc amalgam, nitric. No, this is the option. Zinc amalgam and HCl. Easy. Next question. Short answer type question. Now after the MCQs, now I'm going to the short answer questions. Let us see how we will answer the short answer question. Why there is a large difference in boiling points of butanol and butanol? They're asking me to compare between an aldehyde and an alcohol. Correct? All right. So first of all, butanol, CH3, CH2, CH2, butanol. Now butanol, 1, CH3, CH2, CH2, okay, CH2 and OH. This is butanol. Now when you compare both of them, what is required for boiling? First of all, whenever you're adding something into water, then only we talk about boiling point, right? Point at which it starts vaporizing at 100 degrees. Now, in both the cases, they said large difference in boiling point of both. In this case, there is intermolecular hydrogen bond. Correct? There is OH group. In this case, it forms again hydrogen. In this case, OH, like that. Intermolecular hydrogen bond. So this butan one all has intermolecular hydrogen bonding between OH groups of alcohol. OH groups of alcohol. But in case of, I don't know, but in case of aldehydes, no such hydrogen bonding observed. Hence, 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 BP is less. So in this case, the boiling point of butanol is almost, you can write here, 391 Kelvin. 91 Kelvin is a boiling point of butanol. Alright students, easy. Next question, let us read. What right it is to differentiate between pent and 2-one and pentan 3-one? Okay. First of all, write the structures first. Then it is easy. Pent and 2-one. What is the structure of pentan 2-one? Simple. CH3, CH2, H2, E double bond OCH. What is pentan 3-one? Pentan 3-one. Okay. So Pentan 3 on same thing. C, now CH2. Now it is C double bond O H2, the third carbon. Now in this case, what is the difference? This methyl ketone is a difference. Correct? This methyl ketone, simple. Methyl ketones give which test students? They give iodoform test. Correct? Now they give iodoform test. Simple. They show positive iodoform test. I can easily write down. Pentan 2-one has CH3 group and it gives positive iodoform test, but pentan 3-one doesn't. So what will you write? Hence, here. Write this, show this, H2, 2, double bond, by methyl ketone, mark it like this. Then you write iodine, and you write sodium hydroxide, and you write iodoform test, and write the compound. One is the LOPPT of iodoform, and next is your sodium, or because sodium we are taking, you get sodium butanoate, a salt form of that sodium butanoate. So this is LOPPT. Write it, LOPPT, and here you will write sodium butanoate. Sodium butanoate. Right, students? Butanoate. Now, in this case, before I go to the next question, so because of this, so you write here because of methyl ketone, it shows positive iodoform test. Iodoform test. And here no methyl ketone. No, there's no methyl ketone. No methyl, not methyl ketone, not methyl ketone. Hence, does not show iodoform test. Does not show iodoform test. Is it okay? Easy. Next question. Give the IUPAC names of the following compounds. IUPAC name easy, my favorite actually. Alright, let me start. I have a place for this. Yeah, I have a place. So I'll write one here and then next one we will write. First compound, from where should you start naming, students? You have to start numbering from the functional group, correct? Yes. So let's start. But here there is a double bond also. There is a phenyl group also. So how will I name it? P. 2. This is prop. Okay. So first comes 1, 2, 3. All right. First 3 phenyl. Okay. Then how many carbons? Prop. 3 carbons. Where is the double bond after the functional group? This is the second carbon. 2 ene. Correct? Now this is 1. This is 2. 2 ene. After that, this is in the first carbon, second carbon, third carbon. So 2 ene, 1 al. 1 al. That's all. First one. Second one, students. Second one. Second compound is nothing but cyclocompound, right? Let us write the structure. Yeah. This is your compound. This is your CHO. So name it cyclo. Okay. Hexane. 6 carbons. Carbaldehyde. Cyclohexane carbaldehyde. This is the compound. Third compound. Let us write the third compound. What do they give me? The 1, 3, 4, 5. Let us write that. 1, 2. Oh, this carbonyl compound. Okay, third one. Okay, let me erase that. C double bond O, CH2, CH2. Right. So this is which compound, students? This is O, C double bond O. Correct, right? So we call it as oxo. Oxo. How many carbons are there? 1, 2, 3, 4, 5. Pent. Easy. So write down 3 oxo, capital O, oxo pentan 1L. Okay, fourth one. The compound given me 1, 2, 3, 4. Okay, easy. 1 H double bond CH. Okay. So what is the name of this compound? How many carbons? 1, 2, 3, 4. So start put 2 in 1 L. That's all. Easy? Very easy. Next question. Give the structures of the following. They asked me to write the structure of the following. One is 4-nitropropionone. Okay, first one let me write here, students. 4-nitropropionone. Okay, first of all, phenone. Let me draw the, okay, done. Basic. 4-nitro. This is 1, this is 2, this is 3, this is 4. This is 4-nitro. Okay, nitro is done. Propionone. Prop. CH3. Okay, then CH2. Okay, then phenone. C double bond O. Done. So, see here, this is 4-nitro propionone. Done. Then they asked me 2-hydroxy cyclopentane, not plus, cyclopentane carbaldehyde. Okay, 2-hydroxy cyclopentane carbaldehyde. Okay, carbaldehyde, cyclopentane. First, let me draw cyclopentane. This is my cyclopentane. Then they asked me carbaldehyde, 2-hydroxy. So this is first carbon, this is second carbon, 2-hydroxy. Then this cyclopentane carbaldehyde. This is my carbon. What is the C part, students? They asked me phenyl acetaldehyde solution. Okay, phenyl acetaldehyde solution. Give the solution is what they asked. Phenyl acetaldehyde solution, don't get confused. Phenyl acetaldehyde. So one group. This is my phenyl group. Acetaldehyde. Phenyl acetaldehyde. That's it. Solution is it. So next question. Write the IUPAC names of the following structures. Okay, easy, students. First one, 2 carbon atoms are there. So it is ethane 1,2 diol. Correct? Okay. Second one, 2 benzaldehyde groups are there. Benzene 1,4 dicarbaldehyde. Dicarbaldehyde. Third one, it is 3 bromo. Okay. So it is 3 bromo benzal. 3 bromo benzal. Here 3 bromo, 1, 2, 3, 4, 5, 3 bromo benzal. Correct, students? Yes. So we'll do 2 more questions and I'll be sending next video, students. So it's long videos, it will be difficult for you to do. Okay, shall I send this question in the next video? All right. Okay, how many questions are there? We have almost in this, as I said, students, total number of questions almost at 37 questions. In my next video, that is tomorrow, or if possible, I'll try to send one more video tomorrow morning. So please watch one more video. With this, it will cover complete. See you tomorrow. Bye bye. Tomorrow we'll be completing remaining questions. So remaining questions out of 37. So complete remaining questions I'll be completing. See you. Please like the video, share the video. So study this today, students. Total 20 questions is what I did today. Total 20. So total 20 questions. Study this 20 questions. I'll be meeting you tomorrow. Same time. Bye-bye. Take care. If you want the video quicker, let me know in the comment section. I'll be sending it. So, thank you so much.